That goes for raising complex numbers to powers. Now, we're going to have a shortcut we're going to talk about momentarily if I have really big exponents. Now, the squaring, on the other hand, not a really big exponent, not a really big deal to handle. I could think of 5 minus 2i as 5 minus 2i times 5 minus 2i. So I'm taking the squaring and stating what that means. And I would FOIL that out. And if I FOIL that out, I get 25 minus 10i plus 4i squared. I then go through the process. I turn the I squared into -1. I group my real parts and my imaginary parts together so that I can carry through the operations. And I end up with 21 minus 20i. One thing I want you to know is about f. Again, I'm taking two complex numbers and I'm multiplying them together. But these complex numbers have a very specific relationship. And when that relationship exists, something specific happens with multiplication. That's something that we're going to be using as we head into division. So here, I have 4 plus 3i and 4 minus 3i. If I carry through the same procedure, I'm going to FOIL and get 16 minus 12i plus 12i minus 9i squared. Again, the I squared, I'm going to make a -1. And I'm going to regroup to have my real parts together. So 16 minus 9 times -1 is the real part. -12i plus 12i is the imaginary part. The minus 9 times negative becomes a plus 9. So I have 16 plus 9 minus 12i plus 12i. 16 plus 9 is 25. A -12i plus 12i would just cancel me with nothing for the imaginary part. So here's an instance where I multiply two complex numbers together and I get a real number only. Now remember, real numbers are in the complex number system. So I'm not losing any closed system things here, and if worst came to worst, I could write this as 25 plus 0i. It's just, from an algebra standpoint, it's kind of pointless to do that, because that means I have no imaginaries. I have no I portion of the complex number. So we just usually don't write it. This is an instance where I had two complex conjugates being multiplied together. And what a complex conjugate is that essentially I have the same real part and my imaginary parts are opposites. So basically I have the same two numbers, like 4i and 3i. The only difference is one's going to have a plus sign between them, the other's going to have a minus sign between them. That makes them complex conjugates. And anytime you multiply two complex conjugates together, you get a real answer.